Hi guys. This is late, isn't it? So, I think you guys know who I am, right? Pretty much. So if the content sucks, it's my fault. Because I'm the content owner this year for TechEd. But this is what I normally do, is I present technical content. So my name's Jeff, IT Pro Evangelist at Microsoft. I think you heard in the keynote, been at Microsoft for a long time. 24 years, last Friday. So the reason why this session is at this time of the day is we are busting out of the Gold Coast Convention Center as far as the number of sessions that we have, due to the number of attendees, sponsors, and all that. We were going to cancel this session, but we decided to do it on a Wednesday night after the main session starts. So is everybody glad we didn't cancel it? Yes, we were going to do a webinar, but then I thought I've already prepared all this stuff for you guys. So we wanted to make sure we gave you this content that you needed. So we wanted to deliver that to you. So this session's about file servers. You guys got file servers in your environment? Yeah? Lots? Lots of file servers hanging around? How many people got old file servers, like 2003? Other operating systems doing your file serving work? Linux, all that kind of stuff, yeah? All right. Well, I'm going to show you some stuff that hopefully you're going to get an idea of the changes. Because how many of you have 2008 file servers? 2008 R2 file servers. But you still do have a lot of 2003 servers hanging around? Okay. How many of you still have a lot of clients on Windows XP? Okay. When we get to the SMB part of that, we'll give you what's going on and what the benefits you're actually getting. So we'll give you a scenario overview. I'm going to give you a lot of examples of some of the scalability testing that we've done at Microsoft Incorp in the US. I'm going to talk about that scalability, talk about the name consolidation problem, because what typically happens is that you get a whole bunch of file shares created. How many of you have duplicate file share names that are on multiple different servers around in your organization, right? People just create file shares and they give them all these common names like sales, marketing, finance, but they have them on all kinds of different servers with all kinds of different files everywhere. So we're going to talk about some of the advanced networking, high availability. Okay, there's a lot of content in here. The aim is to finish at 7:45. I'm sure you guys, I probably should have served beer in here at some point, shouldn't I? That would have been that probably would have been a good idea at this time. Hey? Yeah, I mean, the eval forms would probably go up really, really high, right? So there you go. All right, so, when we look at what's going on and why we're sort of in this scenario is that would you guys agree there's server sprawl out there right now with file servers? In the plenary session, I talked about this whole notion of the private cloud and what we're doing around the private cloud. But we're still seeing a whole bunch of file servers as a workload that's out there in your environment, still out there and still something you have to deal with on a daily basis, right? Consolidations means that you might end up with fewer shares running on fewer servers. But you still might be in a situation where you have a point of failure. Because what are your users expecting these days? What do they expect from you guys as IT? Everything to be up all the time and therefore never be a problem, right? So they want their service to have scalability, performance, just add more storage. How many of you have ever heard this? They think you just go down to Harvey Norman and buy a new disk and shove it in the server. They don't get the whole idea of RAID and all that sort of stuff, right? They think disks are really cheap. Why can't you just add more storage to the server? It's all good. The thing that they don't want, though, is that you might have applications that are hard-coded to the paths that they're using for those file shares. Some weird application that requires a map drive or something like that, God forbid. And you've got a path to the file share that doesn't change. And you want to make sure that your file services can be fault tolerant. And we'll talk a little bit about high availability and clustering and what we can do with that service. Okay, so we'll talk about that. They need to be highly available, so you've got a lot of sprawl. There's some consolidation you have to do, and there's some investments. I'm going to talk about some of the scale that we can actually get with this. So first of all, talk about scalability and performance. First part of this is to talk about scalability and performance. I'm going to give you a sample configuration of all these different spindles. Okay, I'm going to show you some improvements since Windows Server 2003. I think what I see when I talk to customers, when I talk to a lot of people, I think a lot of knowledge that's out there is based on Microsoft's older technology. You know, Windows Server 2003. A lot of you raised your hands. You were still running Windows XP. You're having to support older operating systems, so you might not be familiar with some of the changes we made in 2008 and in 2008 R2. Okay? So a lot of you talked about, how many, show of hands again, 2003 servers in your environment? Okay. 8 years ago that was, or more. Some of the changes we've made from 2003. How many of you are familiar with CIFS? CIFS, the CIFS protocol. Can anybody give me an idea of how long ago CIFS was implemented in what operating system? It's going back before DOS. What kind of files were we shipping around at that time? You know, in the early 90s, when SMB came out, we kind of changed the protocol to the server message block. What kind of files were we shipping around the network? Pretty small ones, right? And the networks weren't really like they are today. We're not moving around those files. So we've had 8 years of integration with file services. We can have more shares, more scalability, huge amount of changes in WAN efficiency with technologies that you're seeing on the screen like branch cache and DFSR that we implemented in Server 2003 R2 and have since improved with 2008 R2. Okay? So currently in the operating system now, in 2008 R2, it's SMB 2.1. Okay, so that is the latest version of the server message block. Back when Windows Vista came out, I know that sometimes can be a swear word in some cases, but you know, that's why you all raised your hand, you got Windows XP. We made major changes to, one, TCP/IP protocol, and we made changes to the server message block. Quite significant changes in Vista. We did make changes to SMB in Vista SP1 because anybody remember in Vista where when we were doing file copies and we were calculating how long that time was going to be? Do you remember this? That changed. So that changed a little bit to get around that particular issue. So you know, some of the metrics that I'm going to show you has been done with a tool that you can download called the File Server Capacity Tool. So if you want to do simulation of common roles that you're going to have in your environment, so users you know, having home folders and that kind of stuff, you can do simulation of this to see whether the hardware that you've bought is going to scale to that number of users. Okay? There's been changes to offline files. There's been changes in what I've heard as being the dreaded check disk. A lot of people scared of running check disk on large volumes. Some stats to show you that's going to give you some stuff there. We changed things like larger MTU, 8.3 naming. I'm going to talk a little bit about the changes we've made in regards to 8.3 naming, okay, and what you can do to improve performance in that regard. Durability is a big thing. We've actually made changes with SMB. SMB durability, you know, if you lose the connection, any of your users got docking stations for their laptops? They have the plug in the back, then they rip it out without actually doing it safely, and then they're trying to go on wireless. They might have a document open and wonder why they get file corruption. So SMB durability is going to help in that particular scenario. A lot of this is enabled by Windows 7 on the client, okay? Because SMB 2.1 is not in Windows XP. It's SMB 1.0. So it's an older version of the protocol, and I'll show you what the difference looks like when we're doing file copies as well. So here's some of the improvements we've made in increased file sharing scalability. Okay, so with SMB1, number of users, 2 to the power of 16. Look at that scalability when we go from SMB2, 2 to the power of 64. I think if you were in the keynote, my head hurt when Adam Spencer started going on about math. Were you guys going, oh, what is he talking about when he started going on about maths? That 2 to the power of 64 is a big number. Okay, so scalability is huge. Open files as well is 2 to the power of 64. Same with number of shares. The thing about the SMB1 protocol, it was a very, very chatty protocol. What did it actually do? It had to do sends and acks, sends and acks, sends and acks, back and forth, back and forth. Couldn't do multiple ones at a time. All right, it would send a send request for that only one at a time. So it's a very inefficient, chatty protocol on the wire. which caused a lot of delays. And also UI, when you were on network shares, did not look very good. So, and what we are seeing is that we've improved performance on asynchronous operations. So we're able to improve the operations on particularly high latency pipelines, okay, where we see high latency networks, okay? And we do larger read writes to get around that particular problem with latency. Now, the other thing we've done is that they went into the developers changed the SMB protocol to reduce the amount of code that was in the SMB protocol to make it more efficient. They removed about 100 commands out of it to make it more quicker, allowing it to be more efficient on the wire, okay? Opportunity codes are increased. You can see that the SMB1 had greater than 100. It's down to 19. This is quite significant, reducing the complexity of the protocol to make it work better. Okay, so we've also done stronger and more efficient security. We moved away from MD5 to SHA-256 to replace that. And the network fault tolerance with durability is a lot improved. And I'll show you that a little bit later on with my demo that I've got here. There's larger MTU support. There's leasing improvements in there as well. So make sure what version of SMB do you think you're running? There's a lot of confusion that I've heard when I've talked to customers. Obviously, if you're on Windows Server 2008, R2, and Windows 7, these two boxes, you're on SMB 2.1. If you're running Windows Server 2003 or Windows XP, you're not using SMB 2. We dial it down. We negotiate back to SMB 1. Okay, so you won't get the efficiencies of copy at that point. So if you're doing, say, Windows Vista SP1 and Windows Server 2008, you're running SMB 2, not SMB 2.1. Okay, it's actually got a .01 blah 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 at the end of the actual version. Yeah, go ahead. SBS 2008. SBS 2008. What does that run? Well, SBS 2008 or 2000. What's the latest version now? 2011 or something like that. So the question's around SBS 2008. That technology is based on 2008. So you're going to be running SMB 2, not 2.1. SMB 2.1 was introduced with Server 2008 R2. Okay. By the way, let's make this informal. Happy to have questions as we go through. So we want to try, we're all here. I don't know if we're here against our will or what, but we're here when we're not supposed to be. So, yes, sir.
Presumably that's on a per client basis. It doesn't, one XP device doesn't go over the whole network.
No, that's right. So if you had, 10 XP clients connected to a Windows Server 2008 R2 server, the server is going to notice that client's XP and it's going to dial down to SMB1. If you have Windows 7 clients on that network, they're just going to get their stuff done a lot quicker. Maybe they'll be able to go home a little earlier at night. I don't know. We'll see. So now, I wanted to talk a little bit about some of the check disks. We've produced a white paper on this. You can download this. If you just do check disk white paper performance, you'll find this. Choose your whatever search provider you want to use. So now, a lot of people have been worried about whether we can do check disks on very large volumes. So the blue line is Windows Server 2008. All right? So less than 2 hours to check disk a volume with 100 million files. That's pretty good. This is the improvements we made. Now, why don't you see Windows Server 2003 on this slide? Why do you think that's not there? It wouldn't fit. The time would be too long. Right? Go down to if we go down to 2008 R2, we've made significant improvements there on the red line as well. Right? That's supposed to be there's 2008 R2 on there. That didn't quite draw out like it's supposed to. So here, when you look over here on a check disk time versus volume size. This is less than 7 minutes on a 15 terabyte volume with 10 million files. Less than 7 minutes. So there's a lot of ANSI, because you go back to 2003, that was not a good experience doing check disk on these large volumes. The biggest issue, though, is the number of files. As you increase the number of files, that's when the time actually gets a bit longer. But we've made improvements to that to make that more efficient when you're check disking those large volumes. Okay? And I'll talk about something a little bit around this particular part here. Now, we support long file names in the operating system, and we've done that for a long time. But what happens when you go and create, this is a really long file name on an NTFS partition? What do? By default, we create an 8.3 extension for that for backward compatibility. What we do in Windows Server is that we obviously want to be on the conservative side and be compatible. All right, so what we do is we create that 8.3 file name underneath. You don't see it, but it's created as part of the file system. This actually creates a performance hit, right? So if you see here on the blue, if we're on 8.3 enabled, right, we're saying creating 100K files in a 1 million files directory. That's time in seconds over there on the left. If we turn this off, it's a registry change that you can make to turn off 8.3 to disable it. What it does is it disables it for all future file creations. Okay, so as you create a new file, that will take that way. Then what you can do is do stripping of that. Okay, so for illumination, you can go back in and you can strip out the 8.3 file name that was created for all the files before you disabled 8.3 naming. Okay, so you can further improve your directory illumination for this. So when you go out and somebody's looking at a file directory with 1 million files, we want to reduce the time it takes for them to traverse that directory. You're looking a bit confused. It's on by default.
So if you want to know before you turn it off?
Hey, if you want to know before it's turned off.
How do you know if it's needed? How do you know if you're going to miss it?
How do you know if you're going to miss it? Okay, I'm not sure if I understand that. What this is really saying here is that by default, like in storage server, for example, this is turned off. Right? So storage server is for storage. But in server 2008 R2 and 2008, it's turned on. If you go into the registry, you can actually turn this off. Okay? It will be turned on for all the files that you've created on that file system already. Then you can go back and you can turn it off, and then you can do the 8.3 stripping out those names as well.
Horrible application writing files that needs 8.3.
You want it. That's why we keep it on, because we want to make sure that we're lean more towards compatibility rather than, this is really just a performance thing that's going to help you make your files and your creation times a lot quicker, and the reading of the directories when you got large files in there as well. So, okay. Did I see a hand somewhere? Or yes, I did. I thought I saw a hand up back there.
If you turn it off and strip the previous 8.3 file names, and then discover there's an application that needs it.
That's the part you got to be careful about. Right? So maybe a good invent.
You can't just turn it back on and
It's a.
recreate those.
I don't believe so. So you've got to be careful about this. All right. We're making you aware of this so that you know about it. Yes, up the back. Yes. So the question's around a DFS. Yep. Well, you're going to have to turn it on or off on both servers. It's a registry setting. Is it, pardon?
Just do an export.
Yeah.
And a batch file will be great.
Yep. All right, we'll keep going because we've got a fair bit of content through. The other thing around DFS namespace is scalability, right? So, how many of you out there are using DFS at all? Okay, quite a few of you. That's really good. Like it. So we've improved performance around standalone namespaces. If you look at 2003, this is our average link creation time for 2003, quite high. Dropped dramatically in 2008, and 2008 R2. The other thing is we've created the number of links from 2008 to 2008 R2. We've gone over to 1,200. This is in thousands. This is like 12,000 performance on domain namespaces. So scalability on these has increased dramatically. We've had additional performance, very large namespaces, up to 300,000 links in both modes. And we've tested up to 1.3 million links per namespace. And there's an article there that you can grab if you want to actually have a look at these scenarios. But the other thing is, how many of you have ever used Robocopy? Yeah. Woo! Robocopy rocks, isn't it? It's built into the OS now. I remember when we first started using Robocopy. I used to work in Microsoft's internal IT department for about 6 years. And I remember when we moved to 2008, the guys in the US couldn't believe how good Robocopy was in the Vista 2008 timeframe. because the files finished before they thought they'd started. It was so fast. So robocopy is really great, and we've added this new switch on WAN-Knish. So the syntax, we've added a multi-threaded switch or /MT switch to go up to 128 threads. Okay? So that means that we can dramatically increase the performance as you add these threads. These days, I don't tend to do file copies with anything but robocopy. Or we have this internal tool called Rich Copy, which is GUI based. I don't have to remember commands, but it's based on the same technology. So it's quite amazing the dramatic improvement in the way that robocopy is working. And it's great that it's inbox. You've got it inbox in the OS with Windows 7 and Windows Server 2008 R2. Now, scalable, looking at these improvements over time. Now, this is giving you some sample kind of scenarios of different throughput of different servers at the time the OS was actually released. Okay, so if you look at time on 2003 server, and then you look at the time for the 2008 server, we did a test on a server that was around about $3,000 with 12 disks on RAID 0. And you can see here on 2003, 1,200 users. Okay? On 2008, 3,200 users. On 2008 R2, it's 4,400 users. What's the bottleneck? Disk I/O. There's always going to be a point where you get to, because you've got a certain number of spindles that's going to take a certain number of users. And so you get to that point, and that's where you get that bottleneck, which is on throughput for the number, which is at your disk I/O. So sample configuration. Now this is some sample configurations that we released in a white paper. So if you look at this, this is when you compare this to 2008 Service Pack 2 versus 2008 R2. So we get to about 4,500 users on this hardware. Now this hardware is one CPU with 2.8 gigahertz, 16 gig of RAM, disks, 24 spindles in RAID 10, and one fiber channel, 8 gig fiber channel array. Okay, where do we hit the bottleneck? 4,500 users, but just by changing to 2008 R2, we're up to 7,500 users, almost double. Just by moving that over. Why? Because more efficiency in the protocol. We hit the CPU a little bit harder. Okay, so we're a bit more efficient on the CPU. We hit memory a little bit. We use the memory a bit more efficiently as well. And you can see that on the disk I/O, we're hitting the megabits per second throughput a bit better. But that's where we meet that, is that disk I/O on the 24 spindles. Moving this up a little bit, we went a little bit further, 96 spindles. We go from 7,500 users to 16,500 users just by moving to 2008 R2. Okay? So we're seeing a big difference. Now, we didn't want to stop there. We wanted to go even higher. 192 spindles, 23,000 users. HP's even done a test where they've got a reference architecture where they're even getting 27,000 users on their particular file server. Where's the bottleneck? There isn't one really at this point, because look at what we've got. We've got 192 disks in RAID 10 and 4 8 gigabyte fiber channel arrays, giving us 601 megabytes per second throughput rate. Okay, so once, this is all an economy of scale. I remember when I was in MSIT, and we were thinking about putting in a cluster, and I had a certain amount of budget. The cluster kind of went a little bit too far over that, so we went with DAS storage. So it's just a matter of how much you can spend on these things, but this kind of throughput and this kind of scalability is capable in Windows Server as a file system, as a file serving operating system. We have that capability in the operating system. I wanted to reiterate to you guys that type of scalability we can achieve today with the right type of hardware. Right, so that's the performance side of things. I want to talk about the file name consolidation issue. Actually, before I do that, I wanted to just switch over to a demo real quick, because I wanted to switch over real quickly and just give you an example of SMB2 versus... Got to really press this, don't you? Oh no, wrong one. There we go. All right, so I'm just going to switch over and give you an example of what I mean by the throughput that we get with SMB1. Type the password right is always a good idea. Hey? Was that just a sneeze? Okay. I'm just checking if it was a heckle, that's all, If I get it wrong third time, we're going for beers, right?
You're buying.
Did I say that? Did I say that? Okay. All right, guys, I want to just give you an idea of what I've got going on here from a demo perspective. So I've got 10 servers that I'm dealing with on my laptop here. So I've got a pretty decent laptop. So there you go. So I've got 10 servers, and what I've got here is standard configuration. And this is, you can go up, Jose Barretta from the file server team did a blog post on how you can actually configure this all on a single laptop. So this is domain controller, 2 servers running in guest clustering, iSCSI target. I've added a 2003 server to show the comparison between 2003 and Server 2000 and Windows 7 and Server 2008. So what I'm going to be doing is I'm going to do a copy from a 2003 server to a 2008 R2 server. Okay? And I'm going to copy the same amount of files from a Windows 7 client to a 2008 R2 server, and I want you to watch what's actually happening. The way I'm actually able to simulate this is I've got a little program that allows me to simulate low bandwidth type situations. It's an internal program called Newt that allows me to go and simulate all different types of connections. And in this case, what I've done is I'm simulating a 60 megabit bandwidth. I had to get the timing right here as to how long it was going to take to copy because you want to make sure this actually works. I can go in and I can choose the latency and all this kind of stuff so that I can simulate low bandwidth networks. The reason I did this is so that I can just show you what's going on from a copy perspective. So I'm just going to turn this on. And this is going against my file server 2. Now I'm going to go over to my 2003 server. And I've got a folder in here in my documents called copy. And inside that folder is a bunch of PowerPoint files, just some random files. And I've got a clustered file server, and I've got a folder on there called file copy. And inside that folder, I've got an 03 folder and a 08 folder. Okay, so the 03 folder is obviously the old file server copy that I'm going to do. Now, I'm going to start this copy off. And if you look at, if I do a ping to my server here, you know, the time I'm actually getting, I've created a slower link. I haven't created one with latency, but I've created a slower link. Now I'm just going to drag this over and start that copy. Now notice I'm not really rushing over to start to do the copy on Windows 7 because I know that Windows 7 is going to finish before. Let me just go to my client here, and I'm going to drag this copy over to the 08 folder. Now let's see if we can get these kind of side by side. Let's refresh that. Geez, it worked so many times well in the speaker room. There we go. Okay, so that's copying that over. Now, the time that's taking, the time we're actually taking for the files here that are on the 2003 server. So what we're doing now is popping to a 2008 server, 2008 R2 server, but because I'm on an older operating system, I'm negotiating back to SMB1. So I'm sending, I'm receiving, I'm sending. What we can do with SMB2 is we can send multiple commands inside a packet so that we're sending more. It's like, say if you wanted to do an egg race, right? And you had one guy standing here, and you need to get 10 eggs over there. You'd have to go back and forth, back and forth. With SMB2, we can send about 5 or 6 eggs all at once. So we can send more across that way. So now let's go and have a look at see how the 2000, oh, bugger, that's a pain in the arse. That's just not cricket, is it? Or as Rick back there would say, it's just not hockey, right? All right, so let's cancel that one. But you see this one here. This one I started after, and you can see. Oh my God. Let's cancel that one. Okay, you can see that I've got 45 seconds going on that one. This one will finish before the 2003 copy because we have a more efficient protocol. It's just an illustration to show you how that copy is going. Now, if you look over on the 2003 server, it's still saying it's got all that time. I've started multiple copies over on the ones that were by mistake, but it still worked out for the best, right? So you can see here 15 seconds remaining, 45 seconds remaining on that. This one's going to finish first, even though I started the copy later and I accidentally started multiple copies there. You can see that that's going to finish well before that. Now, that's just about 394 meg of data. Can you imagine that when you start to get to really large amounts of data? You're going to see, one, you're going to see the user's going to have a much better experience in the way that their UI looks when they're refreshing that screen. And it's going to be a much better experience for them in that regard. So I just wanted to give you a quick look at that. And I'll just go back and make sure that I turn off, because I don't want my bandwidth slow later on. Beautiful, it's switched over. Excellent. All right, let's talk a little bit about networking. Okay, what's the name consolidation problem that's going on right now? Has anybody got this going on in their environment? So you got file 1, orders, sales. File 2, training, software. Then we got another sales folder. What do we do when we go to the new consolidation server? We're going to run into a problem, right? We're going to have all these weird things going on. The goal we have for our users, we want to make our users happy, right? Yeah, maybe? Maybe? Do you want to make them happy? Okay. That's why you're here anyway, right? So we want to try to get to the point where, you know, when we get the new UNC path, we're going to get some conflicts here. So what can we do about that? So there's a couple of things you can do. So you can go and create an A record, which is a host A record, or a CNAME record if you're using DHCP, for each consolidated file server, right? So all shares will show up under any of the names of the IP addresses. So you can go into DNS and you can go and add, this will work. You can go into DNS and you can, each consolidated file server will get a record in DNS. Okay, so that's one way to actually get around this. So you can see here there's a DNS command for this, what my DC is, what my record, do I want a record add for file A, and the IP address of the new consolidated server. Okay, so that gives you the ability to have multiple those DNS record names that then gets mapped over that, so they'll use that. The other option is to do alternate computer names or dynamic DNS. Okay, so you can create an alternate computer name for each of the consolidated file server names. Okay, so you can go, all shares will show up under any of these names. So you can use netdom in this particular scenario. You can go and use netdom, computer name, cfile, add, file 1, 2, contoso.loco in this particular scenario. Okay, so each consolidated file server will show as an alternate computer name. Then you have to do an ipconfig register DNS to make sure that that change happens in DNS. The other thing you can do, and this is something we kind of are recommending, is to use DFS consolidation routes, which is part of the file server migration toolkit. So you can create, you know, the best idea is that you want to create a consolidated DFS namespace, okay? That DFS route for each of your consolidated file servers. And then create links to those old file shares. And each share shows under its specific namespace, okay? Now, you can do this through the DFS util command, or you can automate this process, or you can go through a bouncing ball wizard, right? And you can go through and use the file server migration toolkit. I'm smiling for you. Come on, I know you're there. Yeah, you got a Wallabies jumper. He's pretty good here. This is Rick, by the way. He's a colleague of mine out from Canada. He's part of the Commonwealth, so he does get the jokes. It's okay. So you can do that with this utility, right? So the DFS consolidation routes, we start the wizard. You go through what's your DFS server, what's your root folder, old server names, add those in, and we configure it. It'll go through, it'll make the changes, it'll make the entries in DNS, it'll make those A record settings for you. It'll make any changes if you're using WINS by any chance. It'll go through and do all the things that you need to do to make sure that you've got all the right records. How many are using virtual machines for file servers? Yep. Are you totally moving all your off physical file servers, moving them to virtual machines? Yep. Yes and no? Yeah, mostly? Mostly? So this is another way. You know, when we talk about people that have physical hardware for file servers, which I'm sure there's still a lot of that stuff out there, you can go and create one VM per consolidated file server. Okay? You can use a matching computer name and even a matching IP address. We recommend you leverage the P2V tools, such as what's in Virtual Machine Manager 2008, to do the P2V tools. I've talked to many customers that have used this tool, and they're able to convert physical workloads to virtual machines fairly quickly. Okay, so you can do that. You can leverage that. This is a perfectly good solution to do that. But another one you want to actually look at is different clustering methods. So create one clustered file service, and we call this a clustered group or something like that. So per consolidated servers, and use matching names, okay, for and even a matching IP address. And you'll notice that this actually looks a little bit different when you go into, and I'll show you what it looks like in clustered servers. This looks a little bit different. Essentially what you have is you have a service in clustering, and then you create all your file shares within the cluster administrator, as opposed to going inside the VM and creating within there. So you're managing this through as a service that's highly available using clustering. And that's something you're going to want to do in your environment as well. So I'm going to talk a little bit about the advanced networking capability, DNS round robin, SMP durability, and other things. So you've heard of DNS round robin? Okay, so in this particular scenario, we have a bunch of clients, okay, and we've got multiple NICs in the file server, hopefully. And that's the scenario we've got. So we've got different IP addresses for each of those file servers, okay? 1, 2, 3, just to make it easy for us at this time of night. We don't want to count really too far past 3, right? So then obviously this goes through your router, gets registered with your DNS server, and then what your clients will do automatically is your clients will see an ordered list of IP addresses, and they will automatically use DNS round robin to go and grab that file server, okay? The file server clients will favor the first IP address, okay? And if the client actually fails, the file server, they tend to be distributed across those multiple IP addresses, all right? So SMB durability. Now, how many of you have multiple NICs in your servers? Most of them come with dual NICs on the motherboard, right? Do you use both of them? So you use one and disable the other one? I'll talk a little bit about that in a sec. Most of them have multiple NICs. So an SMB client receives a list of IP addresses, right? It connects to one of them. It's a connection to that particular one. Upon network failure, what happens if the network fails now on that particular connection? They've gone and say they've gone internal 2. What happens when that fails? What happens? Do you think the connection fails? Obviously in 2003, and a lot of the old file servers you have, you're going to have some interruption there. With SMB durability, in the way that we do that, the handles survive. You know, if a user's working on a document, they've got an open file from a share, and you know users don't know the difference between opening up a file from a local machine and a file share. So they do it all the time, right? So the handles are going to survive because SMB, we have durable handles on by default. Okay, so if we have a network failure, the SMB client will connect to another NIC automatically. It'll go and use that, and I'll show you that in a demo in a second. Yes, sir? So questions around NIC teaming? I'm going to talk about NIC teaming in a few seconds, as in different scenarios. With NIC teaming, though, obviously we have a standard spiel, as they say. Not technically supported by Microsoft, but it's supported by the hardware vendors. It's doable, and we see a lot of people do it, but it's a hardware thing. It's provided by your individual hardware manufacturer. So the other thing is that op blocks are enabled, are required for reconnection, and that's something that we've actually added in the SMB protocol is the opportunity locks. The op blocks are a little bit more robust. Now, if you look at this is what the kind of, and I'm going to show you this in the demo. So see in this scenario, in this particular scenario, the DNS NSLOOKUP is actually reporting that this particular server has multiple IP addresses on the file server. Okay, so it's going and have a look. The copy starts on network 1. Network 1 is disconnected, and if we're using SMB2, we're going to automatically switch over to another NIC card without interruption. And I'm going to show you in a scenario that is, it's going to be a fairly mission critical one in the sense that I'm going to have a SQL database on a network share. Not just replicated to the network share, but actually physically on the network share. It's a new part of 2008 R2 of SQL Server. And I'll show you what that looks like in a second. Multiple IP addresses. What you're going to see here is that you can use multiple cluster network for public access and multiple IP addresses for the cluster name. So if you've got this particular workload, I've got a file server service running here, and I'm using multiple IP addresses for high availability for this. Okay, so that if one of them goes down, we're in a good position. So let's have a look at this particular scenario. We're going to show some SMB durability. Okay, we don't need the 2003 server anymore for the time being. So let me just show networking. So the networking I've got in this particular scenario. So I've got obviously a CorpNet connection. I've got one, internal one is used for cluster communications. Okay, so that's for my cluster communications at that point in time. And then I've got two other NICs, internal 2 and internal 3, and these are the two ones I'm going to use for moving my traffic back and forth as I disable these network cards. Okay, and I mentioned the fact that we can have SQL Server in 2008 R2 on SQL Server. We have added the ability to put a database on a file share. Obviously, the same rules apply with SQL Server from a scalability point of view, is to make sure that we can actually do this. So let's look at the properties of this. And if we look at my files, look at where this is located. Okay, so let me just control 1 for those of you at the back, freak you out at this time of night. So you can see here, my MDF, my LDF file is actually sitting on my cluster server, on my cluster. So I can have my database sitting on a file share. This is new in 2008 R2 of SQL Server. Okay? So what I'm going to do here is I've got a database already created, and what I'm going to do is I'm going to start to add some records to this particular. I've got a script that essentially just goes and adds records and does a whole bunch of things and generates some traffic on the NIC card. Okay, so I'm going to go ahead and do that. And what I'm going to want you to do is, you see here now I've got no activity going on these particular NIC cards. So I've got internal 1, internal 2. We've got nothing really going on. And I'm going to kick off this script to generate some traffic on my database. So we'll just go in here somewhere, and we'll execute this. Yeah, I want to select all I do. I don't want to execute just selected. I want to execute the whole thing. Okay, so we're executing that query. And we should be seeing some data going back to my actually, it was on the orders database. Hang on, let me just stop that one for a second. Just a break in transmission for just a moment. All right. Okay. So there we are. You see there's a bit of traffic going on. Okay, so now what I'm going to do is I'm going to start a command prompt, and I'm going to run a command. And essentially, I've got a command that's just going to do an NS lookup, and then it's just going to loop. Okay, so you can see here what this is doing, and I want you to pay attention to what's going on here. So what we've got is we're doing an NS lookup on my Contoso clust FS, and then we're cycling through my IP addresses. Okay, so if I go back over to my cluster and I have a look at how my cluster is configured over here, because I'm using guest clustering, and if I look at this, my file server, right, you can see that I've got these 2 and 3 IP addresses. Okay, so I'm just cycling through these IP addresses and pinging through them. And what I'm going to do is I'm going to show you how the SMB durability with that SQL database allows us to continue executing that query. Okay, so let's go back to our SQL server. Okay, so that ping's going on. And let's go ahead and, which one are we on right now? 2. So we're going to go and disable 2. Don't try this at home. Okay. So go back to SQL Server. Query's still working fine, right? Now what you're seeing, where's the traffic gone to? It's gone back over to 3 automatically. internal 1 network is reserved for my cluster traffic. So I'm not allowing that to happen. But it's gone over to internal 3. Okay, so let's... Okay. Come on, it's only a laptop. We haven't got that many points of failure here. So, okay, so now what we're going to do is we're going to just turn that 2.1 back on. Okay, now we're sitting on 3. We want to make sure that we've got to make sure we get our reply back from 2. Okay, so we've had our reply back from 2. And now what we're going to do is we're going to go, like you said, and disable 3, but we want to turn 2 back on first, right? We're not crazy. So we're going to go and disable that, and you can see what's going to go on. So now you can see we've switched back. So this is really sort of showing you that we're executing a SQL query against the database, new part of SQL Server 2008 R2. I didn't want to just do pings. I wanted to show you something real. So this is against the database, and the query continues to run on that database. So we're showing some, the durability of the SMB protocol is a lot better and gives us that scalability. So let me just go back to, and you can see, records are continuing. The query is running without interruption. What does this mean for your users that are out there? How many times have you had users say the network's down? And you go, what, the whole internet kind of thing? So a lot of times that's just, little interruptions that happen on the network from time to time. And if you can make that a little bit more reliable for them, just by doing, showing this protocol is working better, you're going to get a better experience for them. So I want to stop this query because I don't want this to continue going later on. All right? So let me switch back over. It's a nice transition. I like that. All right. So NIC teaming, to your question about NIC teaming. So essentially, it's kind of a 101 really what it is. It's several physical NICs grouped into one. It's also known as aggregation or load balancing and failover. It's available from most NIC, most hardware vendors, such as Intel, Broadcom, HP, that kind of stuff. There's a support article that has the official statement about what our strategy is on this. But giving you a kind of a screenshot, what HP provides through their HP Network Configurator utility is the ability to take those two, create a team. Intel uses their ProSet stuff, and Broadcom also have software for this as well. So I believe Dell uses Broadcom in a lot of their stuff. HP uses their own stuff in there, so they've got the ability to do that. Your support is through your hardware vendor. Okay. Now I'm going to give you some sample configurations about what you can need to do. What does somebody notice about this slide? There's one that's crossed out, right? What do you think that means?
Don't do it.
Don't do it. Good. If I had beer, I'd give you one, but I don't. So we're going to talk about some different scenarios about how this is actually running. So what happens? Single switch, single client. What do most people do? Disable the second NIC. Why? Why do they disable it? It's wasted. You might as well use it. DNS round robin is going to help you out here, right? Your clients can use that second NIC card, right? So you've got another switch you've got another NIC card that's just disabled. This is probably the lowest level that you're going to get into. It's not a very high availability solution, but you see what happens as we start getting clients connected to this. They're using the same IP address all the time, going through the one NIC card, right? You want to balance that load. NIC teaming, essentially what requires a third-party solution from the vendor, takes those two NIC cards, makes them appear as one. Okay, so makes those particular NIC cards appear as one. Then this one. This is not something we want you to do. Standalone switch, single client on the same subnet. Okay? Technically, it'll look like it's working, but not really. Okay? Multiple NICs on the same subnet is not a supported configuration. Okay? So you can see these are on the same. You want to put them on a different subnet. Now, standalone NIC, multiple switches. This is another scenario to allow for, you're starting to get into the high availability scenario. Okay, so we've got two NIC cards, two IP addresses, switch one going, and what will happen is the client, you see this particular scenario, the client one is going through switch one because in the cabinet, in the closet where the the client's actually sitting, not in the closet, but where the switching fabric is in the closet, they're going to go to switch 1, and the second client's going to go to switch 2. What we're trying to do here is to balance that load and what we're seeing on our file servers, because you can see the more clients we have, the more we actually get into bottlenecks with disk I/O and all that. So if we can balance that a bit better, we're in a good shape. Here's another one, standalone router, single client NIC. In this scenario, what we're doing is we've got 2 switches going through a router. Okay, so this is your server end in the back end, router in the data center, the other switches in the cabinet. Okay, a little bit more layered in the way that that actually works as well. It's ideal for a standalone NIC file server. Could be combined with NIC teaming if you wanted to have a bit more availability and reliability in that particular scenario. Standalone multiple switches. This is another scenario where you've got, this is starting to get a little bit more complicated. You can see here that we've got 2 NICs in this particular one. This is ideal for multiple servers. Typical scenarios like SQL Server using SMB2. So you know how we were talking about SQL Server being able to use this on a file share? You want to get into this scenario where you've got some redundancy going on. Okay, so you got switch 1, switch 2, so they're going through a router to the client networks. Okay. Now we're getting a little bit more crazy. Okay, so here we're talking about clustering, high availability, router, and a single client NIC. But what we're now doing is we're exposing this file service. Okay, so this is clustering the NIC. I showed you this in the UI where I had those 2 IP addresses, 1 and 2, allocated to each of my file server service. This starts to become a service. Okay, so you have a file server, which I have in this scenario. I have 1 file server, then I have a service that I'm using in a clustering type environment, allowing me to, service one of those nodes and patch one of those nodes and move that service across and flex without any downtime for the user, or very little downtime. Then we've got a scenario where we've got a cluster, multiple NIC cards, multiple client NICs. Do any of your clients have multiple NIC situations in their PCs other than the Ethernet and the wireless? So this is a scenario. It could be for application servers like SQL Server, could be combined with NIC teaming on that scenario. So now I'm going to talk a little bit quickly about high availability because I know we've only got a little bit of time left.
Can I ask a quick question?
Yeah, you can, sir.
If you're using some of that clever routing stuff and multi-home or whatever that presumably is better supported in SMB 2.1 than the previous version.
Yep.
If somebody jumps on the network with their Windows XE box, will that fail? Or can you prevent the pooling back to SMB1 and effectively exclude those older clients?
So the scenario, from what I can gather, what you're saying is that so if a client jumps on with an XP box, we're going to get into a situation where they're not going to have durable handles, for example, with SMB2. They're going to be back to whatever SMB1 actually provided them, right? So get them all on Windows 7. I don't know if that's the answer. I know that's not, I understand where you guys are all sitting in your, a lot of customers are sitting in their migration to Windows 7. But that, we're going to negotiate back to what that, and they're going to have that same experience that they had before. There's not much that I know of that you can actually do in that regard, because we're talking about low-level protocols here in the OS. So in this particular scenario, this is, how many of you have heard of the branch cache scenario we have? Because I'm not really covering branch cache in this, but this is the only time that you would actually use it, is that you've got 2 file servers, right, in this particular scenario. One in headquarters and one in the branch, multi-site DFS and offline files. So if you're not using DFS or you're not using DFSN, DFS namespaces in the DFS replication that we've added in the operating system, you should. You should be looking at DFS. One, it makes it a lot simpler for your users, not having to understand. I mean, most of the users I talk to can't understand between backslash and forward slash a lot of the time. You go whack, whack, and they go, what? Go like this instead of like that kind of thing. So, and client-side caching, a lot of improvements around offline files in this particular scenario. This particular scenario here, you're not going to have no open file replication. This is the last writer wins scenario. You get into that situation where one person's writing a file to a particular, it's the same file. It's going to be the last writer wins in this. There could be potential replication delays between this site, potential replication, and it doesn't replace your regular backups that you would normally do. Okay, so there's a potential failure here on the host at this particular scenario. So single site DFS, another scenario, you have 2 file servers. So if you're in a single site, you're going to be using DAS storage in this particular scenario. You do DFSN. One thing you could do in this scenario is that you could have a single site with high, low priority targets, and you could kind of set your low priority shares to read only and make them read write upon manual failures and that kind of thing. So you can replicate between these through DFSR. The good thing about DFSR is that we only replicate the changes that we've made, the metadata, the changes to the files. We don't replicate the whole file. So that makes a big difference. There's no open file replication. Again, this is the whole scenario, whereas the last writer is going to win in this scenario. Okay. File servers plus DFS. The other thing you can do with DFS, you can target priority. Okay, so there's a couple of different scenarios in DFS that you can go in and actually have a look at. Let me just show you this in machines rather than a screenshot. Let me just switch over. So go over to, I'll just go onto my file server here. Don't care about that. So let's go look at this particular one. So you can go and set up how your referrals are working. You can set up how your replication is going to be going on. Let me just... We have an ordering method for this. We have whether we're optimizing for scalability, that kind of thing. I just don't seem to find that in the... Yeah, sorry, let me go into here. This is our overall referral order. So you've got the scenario first among all targets, among targets. So you can go in and tweak this a little bit. You can also do it at the client end for that share. So if you go back and just have a look at this really quickly, is that you can go back here and you can see on the client, we can go into the shares and we can say, what's their priority? What server is going to be their priority? DFS prioritizing that can be used in the UI as well. Here's where we get into something this will hurt your brain at this time of night. So I'm kind of trying to treat this like a user group meeting. Does that make sense? But normally we have pizza. Probably should have ordered pizza. Hey? Developers got pies? Sorry, I had a few other things on. Sorry. I'm really sorry. I had so much to do this year. I'm kind of, my head's spinning at the moment. Yeah, I know, you guys don't care about my problems. All right, so in this scenario, this is active-passive versus multi-active, right? When you come to the world of high availability, I've been, talked to a few different customers about the fact that here you've got shared storage, and this can be iSCSI, Fibre Channel, whatever shared storage you choose to have. And I remember from Rick's session that I was only in for the first part, is when you choose, was that you saying that? If you choose iSCSI or you choose Fibre Channel, stick with it.
Yeah.
Use it, right. So, you've got your shared storage. This server, with cluster shared volumes, which is a new part of Server 2008 R2, is that one of the servers is going to grab the LUNs and grab the ownership of those particular LUNs. This puppy over here, this guy over here is just sitting there waiting passively. Now, a lot of people say, isn't that just like a waste of resources? We've got a server that's just sitting there doing nothing in case of a failure. All I can say is, welcome to the world of high availability. You buy 2 of everything. You buy more than in order to get high availability, you've got to have some reserve there. So we've got our shares sitting on our shared storage, and this one here is in an active-passive mode, 2 volumes, 4 shares. Over here on the right-hand side, we've got dual active, 2 volumes, 4 shares. Okay, so what we've got here is that one of the cluster nodes has got ownership of 2 of the shares. The other one's got ownership of the other shares, and they're sitting there active. So if we have a failure, in this scenario, we're going to fail everything over to the other node. In this scenario, we're going to take half of what that was and move it over to the other node until that's up, and then we'll balance that back again. All right, so it's just a different scenario of how that's going to do that. You have no idle nodes in that scenario over on the right. This one's easier to manage. You have no overload on failure, and you do have a single name. This one you're going to have a little bit more harder to handle. Now, these are just some examples. I'm going to flip through these a little pretty quickly. So this is just that's getting pretty crazy, but it's 2 nodes of Windows Server, shared storage. So you've got fiber channel SAN. So if you've got fiber channel SANs, use them. If you've got SAS arrays, use those. If you've got iSCSI, use that. I use iSCSI. I'm about to set up a private cloud. Dell's given me an EqualLogic SAN. They're really nice. I was really happy about that. With 8 SAS drives and 8 SSD drives, I'm going to be setting up kind of a white box private cloud scenario. So I use iSCSI a lot. You might not know that we've released the free iSCSI software target. It used to be only available with storage server, but it's now available on server 2008. And you can go and set up what I've got set up here by simply running this all in a virtual machine, doing guest clustering. Okay, so that's your iSCSI SAN. It's shared storage, and we're starting to see that these are getting quite prominent out in the marketplace now. So here you can see this is really 2 potential nodes. The file service itself is highly available now. Okay, and we can do highly available DFS as well as high available file servers. And then what we can do is we can migrate these all over, and I'm going to go and do that in a second. Virtual file server, this is just essentially the same thing, but you are running this on 2 different Hyper-V servers. Okay, so you have a potential failure with one host, and then that gets migrated over through live migration. Okay. The other scenarios, this is the host clustering. So there's 2 different scenarios. Host clustering. Okay, so you've got Hyper-V, VM with the file server. So the file server workload is inside the VM. Clustered shared volumes in live migration. If this workload fails, we'll migrate that over with no downtime. We do that within the TCP timeout window, which is got to be within like 2 or 3 pings. Okay. This scenario is what I'm going to be showing you on my laptop, which is the virtual file server on the host cluster. Now the difference in the UI is you see that could be any workload, right? You got to manage how you set up your file servers within that workload. If you do it through guest clustering, it looks a little bit different. It's 2 nodes, different Hyper-V hosts. We'd highly recommend that you put them on different Hyper-V hosts. Not my scenario, I've got it all on the one laptop. What's the single point of failure? If I pull the battery out, I'm pretty stuffed. But it just allows you to test this out. You can do this with evaluation software and have a play with this stuff. So let's have a look at what it looks like. Virtual file servers and guest clusters. Switch over. Beautiful. All right. So first up is I've got my little iSCSI target. So this is the software target. If you haven't seen it before, this allows you to go and create LUNs. And essentially, this is I've gone and created a bunch of virtual disks, one for my witness disk, one for my data storage. You can see here that I've created virtual disk 0. This is LUN 0. And that's a 1 gig witness disk. I've got LUN 1, LUN 2, which is 20 gig disks that I'm using for different types of workloads. Then you can see I've created some for DFS. And if I go in, was there a question? Or a sneeze? Okay. So if I go in and I have a look at my file servers and I have a look at this. So essentially I've called this file servers and we give it an IQN, qualified name here as well. And then I can go in and the iSCSI initiators. These are my 2 file servers. Okay, so on each of my file servers, IP address 3 and 4, they're my IP addresses for those file servers, and those are the ones that are going to be my initiators. Got my virtual disks that are available. Pretty simple stuff to set up with the iSCSI initiator. Allows you to kind of test this out before you want to. You can use a device as your back end to your file servers if you want. So you can test this out with and see what it's like. Now, when you go over to your client, when you're setting this up and you go over to the file servers, and you go into storage, what you're going to see in disk management when you first do this is you're going to see the disks come up as not disks because they've been added. All right. So if we go into to clustering, let me just get the cluster administrator. I've gone into storage and I've added these disks as disks that are available. Once I add those disks in, then I'll see them here. Okay, and you see the little arrow. Sorry, it's not in it. So if you see that one there, this particular machine, 1, has ownership of that LUN. Did you see the next one with the arrow down? The arrow was actually down. That means that the other node currently has ownership of that and has a drive letter assigned to it. Okay? And then when I go into, you can see this one's got disk 5. Okay, so it's got ownership of that. And these just show up as my LUNs in the UI itself. There's my DFS LUN, my data on my witness disk, and all that kind of stuff. Now, the other thing I've done is, obviously in Cluster Administrator, I've gone and created a service. Okay, so I've got a number of services here. One of the things that I tend to do with I have a whole bunch of servers I run on a 2-node cluster back in Sydney, and I didn't want to risk connecting into that from here. So you can see here that this is a clustered file service. Okay, so it's a little bit different to get your head around the UI. You're not going to use the file server resource manager to go and create your shares. Right, you're going to go and create these in the cluster administrator. So you can see here that I've got these IP addresses that I was talking about before, 2 and 3. I'm using those IP addresses. Those are online. This is my server, my properties of my service. Okay, so this is going to be called Contoso file service, and it gives me some policies and stuff like that I can actually do. When I do a start run to that, it just comes up like any other share. Excuse me. Right, so you remember I was talking about my SQL database before that was on that share? It's just approved orders and sales, MDF, sitting up on that in my clustered file share. So you can see I've got my security, my signing certificates there as well. So now if I had to do a patch or if there was some sort of failure with this, I can take this workload and I can simply move it across. And that's going to take that workload and it's going to move that across to the other node. All right? Pretty simple stuff to be able to set up. It gives you some high availability in that. And of course, the speed of this is going to be relying on a number of things. Your fabric controller, how fast your disks are. I'm running this on a laptop. That's not too bad. I've got a 2.5-inch disk in my laptop that gets 85,000 IOPS. It's a pretty good SSD disk. I can start 10 virtual machines in about 15 seconds, all running server stuff. So it's a pretty good disk. I was hoping that was the pizza guy, but it's not. So it's pretty simple to go and create this service. You just go in and you say, I want to configure a service. And these are the services that we can make highly available. And you can see file server is one of the workloads that we can add as a highly available workload. Okay, so I can go in and I can do DHCP server. You can see I can go and do a DFS namespace server as well. I don't have DHCP on this because DHCP is dangerous when you're doing demos. Don't want to put it on the corporate network. MSIT doesn't like that, rogue DHCP servers. So now when I've got my file server, how do I go and add a new file share? You can see all my shares that are there. I simply do this through here. This is going to fail. Now I'm going to tell you why this is actually going to, oh no, it worked. Demo gods in reverse, that one. So here I can just go and I can browse, and you can see it's created an X disk. It's going and created this disk where I can go and create my file shares. So all your file shares get created and are highly available through your cluster, in the clustering scenario there. So that just gives you a high availability scenario. And you can go and set up, if you guys want to go and play with this and experiment with this, there's about 5 or 6 servers you can set up in host clustering. You need, this machine I currently have, I'm running it all on a laptop, 16 gig of RAM. You probably need about 8 gig on your laptop. Run Hyper-V with dynamic memory. You get 2 file servers running guest clustering. You get a nice SCSI target, SQL server, and a domain controller. And you can play with a whole bunch, and there's instructions on Jose Barretta's blog on how to actually set that up. Fairly simple stuff to set up, but it gives you you get the opportunity to test a whole bunch of technologies all at once in one kind of contained small package. All right, we're almost out of time. So I want to talk about some of the things obviously there's some related features that we didn't talk about. Obviously, offline files, folder redirection, they're gonna touch the file server scenario. Branch cache, I think I'm pretty sure there was an instructor-led lab on branch cache. Is that right? Did anybody go to that? Okay. Branch cache, very, very cool. And I believe I saw as I was walking through the lab something on file classification infrastructure. Did anybody go to that one? So file classification infrastructure is really to help you classify the data that you've got in your organization, allowing you to get around these when what is it? Somebody give me the word I'm looking for. You know what I'm talking about. Hey? Taxonomy. It allows pizza. Compliance with all these HIPAA and all these kind of stuff, making sure your data's is compliancy. So that was added into R2 as well, the file classification. Done a lot of stuff around NFS for network type environments and Windows Server power optimizations through core parking, and the file server resource management. The other thing I would recommend, Rick, can you do me a favor and stand up? I'm going to embarrass him, right? Rick, he's doing a session tomorrow called Get Out of Dodge. Right? Migrating from...
Server 2003 to Server 2002.
How many servers do you migrate tomorrow?
I do
6?
DHCP, file, prints, certificate services, and
So that, you got to get along to that session if you want to find out how to get... a lot of you guys raised your hands. You've got 2003 servers, right? You want to find out how to get off them? Go and see that session. I saw that at TechEd North America, and which is why we got him out here to do this. So it's awesome. So... Hey? AM or PM? No, we're not doing any more of this. This is it for the after hours. We call this Tech Ed After Dark. Right? So, okay, guys, I'm almost on time. So really, hopefully in review, that you can see that, the Windows Server platform as a file server is really made some improvements since 2003. We've got really good scalability. We're able to deliver a lot of technical improvements. The guys in the file server team are really starting to get down and improve the base protocols. We're talking low-level protocols that we've made changes to. Hopefully you've seen comparisons between some of the different configurations. Obviously, a lot of the slides that were there are just reference for you later on so that you can actually get those. So my blog is blogs.technet.com/Jeffer36, which my Twitter hashtag is Jeffer36. Simple one. I'll tell you over beer why I chose 36. I don't know. But two resources that you want to actually go and have a look at is the File Cabinet blog. These guys talk a lot about, this is the File Services team's blog. They talk a lot about DFS, DFSR, SMB, a lot of the changes in the operating system. They've written a number of articles about the changes we made in 2008 if you want to get the background on what we've done. And Jose is the guy that works in that team that's done a lot of that stuff. So we're giving away these. I think 10 a day. So evaluation forms, very important. Now, I think you guys were in the keynote, and Nick was telling you about how we do look at the content. We do look at your feedback. Please tell us, was this a worthwhile idea, keeping the session and not canceling it and doing it as a webinar? Was that a good idea? Was that you guys happy to come? You guys rock, man. I can't believe you stayed this late. So I appreciate it. Give yourselves a hand for staying this late. I appreciate you doing that. So I'll take your questions now. We've got a few minutes. Up the back. I know you. How? So what's the best way I've come across? So this is file locks. Do you mean like when people are opening up files at the same time, that kind of stuff? At this point in our technology, it's the last writer is going to win still in that replication scenario. I haven't heard of anything myself. If anybody else has heard anything, I haven't heard of anything specifically. Sorry?
I think it's about a couple of grand a server. It's a small company that puts out, they send over like little small files and then tell you if it's locked on.
Do you have an idea of what you can't remember what the name is?
Google.
We have a comedian in the room now. Or Bing, whichever you want it, you know. So,
I looked at it a while ago, I can't remember.
I know, it's one of those things you wish you wrote it down, but
We use Peerlock for that.
you use Peerlock? I haven't, okay. Mixed, okay. Mixed results, not so good? Okay. Okay. Any other questions, guys? Ah, yes. Young man over here. How are you, buddy?
All right. I'm working with a client at the moment who, how do I describe this? Hoards data would be the best.
What's that?
Hoard data. Cannot leak data.
There's a reality TV show on called Hoarders, I believe, isn't it?
Very much needs to go on that show.
Right.
It collects large quantities of files, goes through roughly about 16 terabytes of the file storage every 6 to 8 months. The strategy has been to just
Keep adding storage.
bigger servers, migrate everything across to bigger servers and everything else. Is there any way across multiple servers to present a single file share that's maybe, say, sales data or something, but data's spread across 3 or 4 servers still? I know sort of DFS will do a namespace and store it on multiple, but actually have that data across multiple servers.
So the question, are you looking to get like a report on what's on those?
Have the user being able to go to, say, DFS share or whatever it is, like some sort of file share, and all the data in that file share is actually spread across 3 or 4 servers.
Yeah, with DFS replication.
But that's going to have the same data on all of them. I need to have different data on them.
Different data. Oh, okay. Okay, so different data across all the different shares.
At the moment, I've got a script that's basically going through and tying it all up in a single share using
Yep.
links and PowerShell.
Yep.
It's not not a clean solution, but it provides what they're after.
Yep. You're probably doing about as the best thing you can do right now at this point. But are you doing any kind of classification of their data at this point in time?
Not at the moment.
Because you might want to explore the file classification infrastructure, because I remember going through this when I was in MSIT. We used to have, I remember we went through a consolidation. We looked at all the data that we had on our servers. 60% of it hadn't been touched in 2 years. But I still had guys saying they wanted to keep files from the Windows 95 launch. I'm going, come on, give me a break, will you? Well, just go up to Harvey Norman and buy some more storage. So we had to use some third-party stuff to be able to go and do this is before we had file classification and we had the ability to do quota and all this kind of file screening and all that kind of stuff. But if you run through the file classification, you should be able to get some reports on we can do age data and all that kind of stuff in the box. What's being used as the file server?
Currently, it's the Server 2003 server.
Okay.
It's being scheduled when they go up to the latest, the next 40 terabyte upgrade. It'll be Server 2009 R2.
Okay. Yeah, that's what you're going to need to get to, because there's not really a heck of a lot in 2003 to help with that.
Doesn't Home Server 2003 support extended disks? Are you guys putting out Home Server version 2011 with it as well or something?
What's that?
Doesn't Home Server version 2003 support extended disks, disk extender?
Drive extender.
Yeah.
That's in Home Server V1.
What happened to V2?
There's third-party tools that use it. Right, so I have a home server. You know I have a home server at home, right? So I use Drive Bender. That's a really interesting name for a product. We'll just bend it and it works, kind of thing. There's about 2 or 3 plugins for home server that do this whole thing that Drive Extender used to do. I've played around with a couple of them, but I haven't really worried about it too much. You know, I put my stuff in the cloud, you know, that kind of thing. I use Carbonite to back up all my stuff, pictures of the kids. Yeah, there's RAID. Yeah, that's the best thing you want to do, man. Yep.
Highly available file servers on virtual servers using Fibre Channel.
Highly available file servers.
Virtualized using Fibre Channel.
Yeah. And you mean, no, you're talking about host or guest clustering? No. You want to use host clustering in that scenario. Hey? You'd be doing it host. You'd be doing host clustering, right? Not guest. All right, guys, we're 10 minutes past this. I thank you very much for spending the time late to come and hear me talk. Enjoy the rest of Tech Ed, and I will be running around with my head cut off most of the time. So we'll see you later.